Okay, so 12.3 today, this is where the lecture starts. There's some stuff about what's called a tangent line. If you remember the tangent line from your geometry days, it's a line that intersects that curve. We talked about it with circles. The tangent line intersected the circle at exactly one point. Now with this parabola, they're showing you a bunch of different tangent lines that are intersecting that parabola once. So I wanted to show you this. This is kind of a definition of what's called a secant line also. A secant line intersects the circle twice. So if you look down here, they're showing you the difference between the red secant line and it looks like maybe a purple tangent line right here. So the red secant line could approximate this whole curve. So I'm picking a dot down here, another dot or point up here. That red line is not exactly the same as the curve, right? But it's pretty close. So we could calculate the slope of that red line and say it approximates the same slope or growth pattern of that blue curve. The tangent line then is sitting down here only intersecting once. So right here they're saying the secant line is what you call an average rate of change. Average rate of change. Then if we look at just the tangent line, you can use that to find derivatives, the slope of the tangent line. And that allows us to find what's called an instantaneous rate of change, which is actually the derivative at that point. So derivative helps us find instantaneous rate of change. And this this picture is moving, so it's going through
Fundamental theorem of calculus.
Yeah. So watch, they start out showing you what we use the secant line. They pick 2 points, and as I slowly bring one of the points in, the secant line, as I get arbitrarily close, those 2 dots move arbitrarily close, and that's what they're showing you as the picture changes. There it changes. The secant line then actually just kind of morphs into the tangent line. The 2 dots that we use for the secant line get so close, we would just say, okay, you're actually moving into 1 point. Got it? Are you watching that?
Yeah.
What's that? What? One of the dots. That's kind of the point, is that I can pick a smaller and smaller secant line on either side of what you're doing for a tangent line, getting closer and closer and closer, and what we're finding then is the derivative. So, that's what they're talking about. Different tangent lines. So that if we took this curve, they're saying approximate the slope at -1, 1. Slopes really, up until now, we've only talked about it with linears, but that dot would be about right here. So let's see if I can grab those. So if I draw a straight line, and then I bring it up, so it just intersects.
Does it matter how rotated it is?
No, I'm really trying. I don't know. What would you say the approximate slope is?
-1/1.
Maybe somewhere around -1. It's not the best, but part of the issue we're having is the scale right there, and that from going from 0 to -1 is not even close to 0 to +1 on the y-axis. This thing, that space right there, That's a pretty big space. So somebody didn't do a very good scale. But the point is, the tangent line is just touching there, and we can use its slope to kind of estimate instantaneous velocity right at that particular point. So what we're going to do, don't worry about it. You talk more about it in calculus. So the slope of a secant line is given by what's called the difference quotient. So if you hear me talk about the difference quotient, Q-U-O-T-I-E, difference quotient, I believe, yes. The idea is we're going to pick some x value, we're going to have some input in our function, and the plus h is just move a tiny bit away, because what we're going to do is let h go to 0, right? So if you pick a dot and you move just a tiny bit, arbitrarily small point away from it, now you have kind of a secant line, you have 2 dots there. And then you divide it, the h off is what you're technically doing. So mathematically what this does is helps us calculate derivatives. So when you guys go on to calculus, you will actually study this difference quotient a little more in depth than what we do, but that's how you will start with derivatives. You'll use the difference quotient. So find the slope of the graph of this function, and then we're talking about finding it at that point. So we're going to do, I shouldn't go up so far so you can see it. We're going to follow the difference quotient. So in this case, if they're finding slope, we can just say, okay, the slope will be given by the limit as h goes to 0. You're supposed to put x plus h into your function. That's what it says. Put x plus h into f. So this would be x plus h squared plus 1. Right? My function is x squared plus 1. So I square the input and plus 1. Then what does it say? Then it says subtract the function. Well, that's x squared plus 1. And then it's all over h. So any questions about where I put stuff?
What's the difference between
So now we're doing the limit as h goes to 0. We need to FOIL that out. It's x plus h times x plus h, which is x squared plus 2xh plus h squared plus 1 minus, let's go ahead and distribute, minus x squared minus 1 all over h. What can we do? Well, there's an x squared, negative x squared, 1, negative 1. Notice all the terms that are left on top contain an h. If you use the difference quotient and you've done it properly, everything left after you do all your crossing off should have an h in it, so that you can do what?
Factor it out.
So you can factor an h out, which would leave 2x plus h. What can we do now?
cross out each?
And now you have the limit as h goes to 0 of 2x plus h. This is the first time now, once we got rid of the h on the bottom, this is the first time that I can take the 0 and plug it in and, the direct substitution and not have any issues. So we're going to take the 0. H is 0, so what happens when the h is 0? I'm left with 2x. So that is the derivative, that is the equation of the secant line, all this stuff. They want us to calculate the slope. So that is my answer, but we have to identify the slope. So, what? That's the equation of the line. Now we're going to take the slope and we say the slope at x equals 1. Because that's the point they want us to look at. Up above it says 1 comma what?
2.
1 comma 2. So at an x of 1, what's your slope?
M.
2 times 1 or 2. Now, if you would graph this curve, right? The line was what? X squared plus 1. We had a graph that was approximate x squared plus 1. And they're asking us to calculate the slope when x is 1, which would be when x was 1, y was like 2 or whatever, I don't know. So you'd have a positive slope right there if you drew your tangent line or secant line. If you're on this side of the curve, your answer would be negative. So you can kind of visualize your own answer.